Okay, we're back, and today we're going to talk about a second exploration with this unit circle. So we have our puzzle pieces. We want to find the degree ring. All right, we've got our degree ring. Oriented it in the correct position, 0 degrees to the right. And we're going to take out one of the sectors of the circles, the pie-shaped wedge, and place it in the first quadrant, aligning it with the x-axis, the little arc. All right, so we've got one wedge here. And then we're going to compare that radius of the circle to the arc length. Okay, so here's the radius of the circle. And the arc itself is that same radius. So the wedge is made so that this distance is the same as this rounded distance. Okay. And then compare this. So the central angle of this circle is an arc of 1 radian. The central angle has an arc that's 1 radian. Place 2 more sectors in next to the original one. How many radians are in a semicircle? Well, there's 1 radian, 2 radians, 3 radians, but it's not exactly 3 radians. It's a little bit more than 3. 3 radians, 3 radians. Oh, this is pi radians for 180 degrees is pi radians. So there are pi radians in a semicircle. That would mean it would take about 6 of these, a little bit more than 6, 3.14, 6.28 of them to fill the whole circle. So there are 2 pi radians in the whole circle. So if a semicircle is pi radians, then a fourth of a circle, half circle's pi, fourth of a circle would be pi over 2, half pi. This is pi radians, and that would be a half of a pi, so pi over 2, or 1/2 pi. Okay, so we're going to label this unit circle. Pi radians is a semicircle. This would be a half pi, or pi over 2. So 1 pi over 2, 2 pi over 2. Ooh, this is 3 pi over 2. And then 4 pi over 2, or 2 pi. Okay, so try the next one. Well, this one looks like that semicircle is split into 4 pieces. So instead of pi over 2, this would be pi over 4, a fourth of a pi. 1/4, 2/4, 3/4, 4/4. So 1 pi over 4, 2 pi over 4, which is pi over 2, 3 pi over 4, 4 pi over 4. So that would be 5 pi over 4, and 6 pi over 4, which is simplified to 3 pi over 2, 7 pi over 4, and back to 8 pi over 4. That makes sense. Okay, now this one, my pi, my half circle, has been split into 3 pieces. So this would be 1/3 pi, or pi over 3, 2/3 pi, 2 pi over 3, 3/3 pi, that makes sense, that's pi, 4 pi over 3, 5 pi over 3, and 6 pi over 3, 0 or 2 pi. All right, and finally, this one, okay, so my semicircle, my half circle, my pi is split into 1, 2, 3, 4, 5, 6. So this is pi over 6, 2 pi over 6, but 2 pi over 6 is the same thing as pi over 3. 3 pi over 6, that's the same as pi over 2. So 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, and 12 pi over 6, which is again 2 pi. Okay, so find the radian rings. So we've got a radian ring apparently here. Quadrant. Ooh, some saw yesterday. Radian ring. There's my 0, so that looks like it needs to go here. Pi goes there. Okay. So pi over 2, 3 pi over 2, pi over 4, 3 pi over 4, 5 pi over 4, 7, but it looks like we're right. 11 pi over 6. Okay. So compare the 45 degrees angles with the radian measures, and what do you notice? So 45 degree angles are these guys, and I'm at a pi over 4 and a 3 pi over 4 and a 5 pi over 4 and a 7 pi over 4. So it looks like 45s always have a 4 in their denominator. We have the radiant ring in the plane, place the 30 degree angles in the plane. So 30 degree angles were these little guys. So that was a 30 degree angle. And here was a 30 degree angle. So that's a pi over 6 and a 5 pi over 6. And if I flip them, I'm at 7 pi over 6 and 11 pi over 6. So those look like those are pi over 6 angles. 30 degrees has a 6 in the denominator. And then the 60s, grab these, and we're at a pi over 3, a 2 pi over 3, 5 pi over 3, and a 4 pi over 3. So those have a 3 in the denominators for the 60 degree angles. Okay. I think that's it for there.